Okay, Module 1, Lesson 2, Calculations with Significant Digits. So for this lesson, the goal is, the learning goal is use significant digits to report. Okay, let me start over. Module 1, Lesson 2, Calculations with Significant Digits. For this lesson, the goal is you'll be able to use significant digits to report results of calculations involving measurement. The way that you'll know you have mastered this lesson is you can perform computations using significant digits, explain the loss or gain of digits in calculations involving significant digits. Before we get into the new stuff, you would have to review rounding. So we did this in the first lesson for this module, but now it's using significant digits to round. So number 1, rounding 0.04738 to 3 sig figs. Right, so we want 3. Looking at this number, the left-hand zeros would not be significant, and you would start counting at the 4. So 4, 7, 3, that's our third significant digit, right? The 4 is not a 0, so it's definitely significant. 7, same thing. 3 is the third significant digit. So this is a number we're rounding. Because we look to the right of that number, that 8 tells us we need to round this 3 up to a 4. And everything to the left stays the same. So 0.0474. That would be rounding to 3 significant figures. The second one asks us to round 736.5 to 2 sig figs. Again, we started at the left of our number. That's our first significant digit because the 7 is not a 0. 3 is our second significant digit. So this is a number we're going to round either up or down. The 6 on the right of it tells us to round up. So we're going to have 740. So we're going to have 740. This is because the 6 turns into a 0 to hold the place value. And that 0 is not significant. If you were to put a decimal and then another 0, those zeros would be significant because of that decimal. So we don't want to put the decimal there. We just want to leave it at 740. This is only 2 sig figs in our answer. Number 3, 1.2904 to 3 significant figures. Here again, we start on the left. This is our first significant figure. This is our second significant figure. And the 9 is our third significant figure. So these are all non-zero numbers. They're definitely significant. Looking to the right of that 9, we have a 0. That means we're going to round this down. The 9 doesn't change. The answer would be 1.29 for that rounding. Okay, so I have to always box my answers so I can find them later. And the vocabulary for this lesson, vocab for this lesson is rounding, making a number simpler by keeping its value close to what it was. So if you're rounding like to the closest tens place, this would round down to 70 because 73 is closer to 70 than 80. But 78 is closer to 80 than 70. So that is how this rounding would work. The concepts in this lesson, right? Concepts for this lesson include adding and subtracting. When we add or subtract, we're reporting on precision. We report the precision as the least precise measurement. That's going to mean that we're going to use the least amount of decimals in whatever we are adding or subtracting. For example, if we are calculating how much 4.5 plus 2.17 is together, we're going to round that to however many decimals the least that there are the least of. So here there's only one decimal place, and in this one there's two. So which one is less? The one with one. So our answer should only have one decimal place. So we can add these 0.5 and 2.17. There's nothing here, so 7 plus nothing is 7. 5 plus 1 is 6. That decimal gets carried down. Here we have 6.67, but since we have to round to one decimal place, we have to round this 6 because a 7 is closer, is over 5. That means we're going to round this to 6.7. That would be our answer for example 1, adding. For subtracting, it's the same thing. So 15 minus 5.6. Because this number here is a whole number, it has no decimal places, and this one has one decimal place. Our answer would have no decimals in it, just like the one with the least. All right, so answer has no decimals. Wait till this focuses. Since the answer is not going to have any decimals, we could just subtract this. 15 minus 5.6. When you subtract, there's nothing in this place. We're going to borrow from the other side. This one goes down to 0. This one, you add 9 to this place, so you'd have 14. And this one, because it's a 0, we're going to add 10 to it. We get 10. 10 minus 6 is 4. 14 minus 5 is 9. So we get 9.4 here. 9.4, it needs to have no decimal places. So rounding to the whole number. To the right of it, there's a 4. That means we round down. Our answer should just be about 9. Next concept is multiplying and dividing. So with multiplying and dividing, we're reporting with the fewest significant digits. This has to do with accuracy. So for precision, you're counting decimal places, and for accuracy, you're counting significant digits. We need to report the one that has the least amount of significant digits in it. So here, find the area of a parallelogram with the height of 12.1 inches and a base of 6 inches. So parallelogram, the area is always going to be length times width, or base times height. So here, the base is 6 inches. We're going to multiply that by the 12.1 inch height. These are both in inches. So our answer will be in inches squared. Right? Multiply something by itself, it's going to be that squared. So 12.1 times 6. I get the answer, let's see. 12.1 times 6, we get 72.6. Let's leave that here for now, 72.6. But we want to round our answer to the least amount of significant figures. So here, 6 is only one sig fig, and 12.1 is 3 significant figures. So we're going to go with our answer that has the least amount, which is just 6, because there's only one significant figure. Our answer needs to have just one significant figure. Counting from the left, I have here the 7 as my first significant figure. Looking to the right of it, there's a 2. That means I round down. My answer is 70. I replace the 2 with the 0 to hold the place value. Here, 70 inches squared. Another example for multiplying, I'm going to multiply now 17.3 times 6.2. Again, just 17.3 times 6.2, I get 107.26 as my answer without rounding. But then when I round, I'm going to look for which one has the least amount of sig figs. This one has 1, 2, 3 significant figures. This one over here has 2. So my answer should only have 2, right? 2 is less than 3. So here, I look at the first number, that one's significant, so that's my first sig fig. The 0, because it's between 2 non-zeros, it is significant, so the 0 is the second significant figure here. Looking to the right of it, we have a 7, that means we're going to round that 0 up to a 1, and we're going to change that 7 into a 0 to hold the place value. Now my answer has only 2 significant figures. So 110. Our next example is going to be with division. With division, we have 8.071 divided by 4.216. This is going to be the same concept, counting which one has the least amount of significant figures. Here we have 1, 2, that 0 is significant because it's between 2 non-zeros, 3, 4, and over here we have 1, 2, 3, 4. So our answer should have 4 significant figures. I put in my calculator 8.071 divided by 4.216, and I got this, so 1.91437, and then it keeps going, but we're going to round that anyway. Counting from the left, I need to have 4 sig figs, so 1, 2, 3, 4. This 4 is the 4th significant figure. Looking to the right of it, we have a 3. That means we're going to round down to 1.914.